In a taste of things to come, an unmanned MQ-8B Fighter Scout has provided tracking data for a Harpoon Block 1C missile fired from the littoral combat ship USS Coronado, LCS-4, helping it reach its target a significant distance over the ship's visual horizon. The live-fire exercise took place on August 22 off the coast of Guam, during which the drone rotorcraft worked in conjunction with an MH-60S Seahawk helicopter. As drones and other robotic devices become more capable and numerous, the part they play in the armed forces becomes more significant. Already fifth-generation fighter aircraft like the F-35 Lightning II are seen less as direct combatants than as command and control platforms, and even manned submarines may one day be relegated to coordinating drone fleets of underwater warriors. As military planners become more familiar with drones, they come up with more uses for them. It's a bit like the transition of computers from mammoth, expensive mainframes that experts had only the haziest idea what to do with to the explosion of applications following the microchip revolution that put a PC in every home and office. This is essentially what happened with the USS Coronado. The Harpoon test marks a significant milestone because it shows a new dimension in drone application, not just as an observation platform or remotely controlled weapon launcher, but as part of a team to enhance the capabilities of an already existing missile system widely used by the United States and Allied powers. In addition, it provided a demonstration of the capabilities of the new LCS class of warships when working with UAVs. LCS will play an important role in protecting shipping and vital U.S. interests in the maritime crossroads, says Rear Admiral Don Gabrielson, Commander, Task Force 73. Its ability to pair unmanned vehicles like Fighter Scout with Harpoon missiles to strike from the littoral shadows matters. There are over 50,000 islands in the arc from the Philippines to India. Those shallow crossroads are vital world interests. Harpoon and Fighter Scout showcase one of the growing tool combinations in our modular LCS capability set, and this complex shot demonstrates why LCS has combat as its middle name. The Army is now performing concept modeling and early design work for a new mobile, lethal, high-tech future lightweight tank platform able to detect and destroy a wider range of targets from farther distances, cross bridges, incinerate drones with lasers, and destroy incoming enemy artillery fire, all for the 2030s and beyond. The new vehicle, now emerging purely in the concept phase, is based upon the reality that the current M1A2 SEP Abrams main battle tank can only be upgraded to a certain limited extent, senior Army officials explained. The Army's Tank Automotive Research, Development and Engineering Center, or TARDEC, is now immersed in the development of design concepts for various super high-tech tank platforms, Army and industry developers said. The extensive conceptual work, simulation and design modeling will be needed before there is any opportunity to bend metal and produce a new tank. We've used concept modeling, a senior Army official told Warrior. The new tank will emerge after the Army first fields its M1A2 SEPV4 upgraded Abrams tank in the 2020s, a more lethal Abrams variant with third-generation forward-looking infrared sensors for greater targeting range and resolution and more lethal advanced multi-purpose, or AMP ammunition combining many rounds into a single 120mm round. The AMP round will replace 4 tank rounds now in use. The first 2 are the M830, High Explosive Anti-Tank, or HEAT, round and the M830A1, Multi-Purpose Anti-Tank, or MPAT, round. The SEPV4 variant, slated to begin testing in 2021, will also include new laser rangefinder technology, color cameras, integrated onboard networks, new slip rings, advanced meteorological sensors, ammunition data links and laser warning receivers. However, although Army developers often maintain that while the latest, upgraded high-tech V4 Abrams is much more advanced than the first Abrams tanks produced decades ago, there are limits to how much the existing Abrams platform can be upgraded. A lighter weight, more high-tech tank will allow for greater mobility in the future, including an ability to deploy more quickly, handle extremely rigorous terrain, integrate new weapons, cross bridges inaccessible to current Abrams tanks and maximize onboard networking along with new size, weight and power configurations. Although initial requirements for the future tank have yet to emerge, Bassett explained that the next generation platform will use advanced sensors and lightweight composite armor materials able to achieve equal or greater protection at much lighter weight. Developers plan to build inside and underbody protection from the ground up for the new platform. Army developers said certain immediate changes in manufacturing techniques could easily save at least 20% of the weight of a current 72-ton Abrams. The idea is to engineer a tank that is not only much more advanced than the Abrams in terms of sensors, networking technology, force tracking systems, and ability to control nearby drones and vastly increased firepower, but to build a vehicle with open architecture such that it can quickly accommodate new technologies as they emerge. The Abrams was first fielded with a 105mm cannon, yet built with in mind a potential future upgrade such that it could be configured to fire a 120mm gun. The vehicle needs to have physical adaptability and change and growth ability for alterations as one of its premises, so it can learn things about energy and power and armor. The Army really needs to think about growth as an operational need, a senior Army official told Scout Warrior in an interview. The official said that, for example, Humvees were not built for the growth necessary to respond to the fast emerging and deadly threat of roadside bombs in Iraq. The new tank will be specifically engineered with additional space for automotive systems, people and ammunition. As computer algorithms rapidly advance to allow for greater levels of autonomy, the Abrams tank will be able to control nearby drones using its own onboard command and control networking, service developers said. Unmanned wingman-type drones could fortify attacking ground forces by firing weapons, testing enemy defenses, carrying supplies or performing forward reconnaissance and reconnaissance missions while manned crews remained back at safer distances. Bassett, and developers with General Dynamics Land Systems, specifically said that this kind of autonomy was already being worked on for current and future tanks. Active protection systems are another instance of emerging technologies which will go on the latest state-of-the-art Abrams tanks and also quite likely be used for the new tank. Using computer algorithms, fire control technology, sensors and an interceptor of some kind, active protection systems are engineered to detect, track and destroy incoming enemy fire in a matter of milliseconds. The Army is currently fast-tracking an effort to explore a number of different APS systems for the Abrams. General Dynamics Land Systems is, as part of the effort, using its own innovation to engineer an APS system which is not a bolt-on type of applique but something integrated more fully into the tank itself, company developers have told Scout Warrior. The use of space in the new vehicle, drawing upon a better allocation of size, weight and electrical power will enable the new tank to accommodate better weapons, be more fuel efficient and provide greater protection to the crew. Army leaders said that less volume in the powertrain can help engineer a new platform that has less transportability challenges. All advanced Abrams tanks will be using a mobile auxiliary power unit to bring more onboard electrical power to the platform for increased targeting, command and control technologies and weapon support. Mobile power is needed to sustain future systems such as laser weapons. The Army cancelled its plans for a future ground combat vehicle, largely for budget reasons. Some of the innovations, technologies and weapon systems are informing this effort to engineer a new tank for the future. Design specs, engineering, weapons and other innovations envisioned for the GCV are now being analyzed for the new tank. In particular, the new tank may use an emerging 30mm cannon weapon planned for the GCV, the ATK-built XM813. The XM813, according to Army developmental papers, is able to fire both armor-piercing rounds and airburst rounds which detonate in the air in proximity to an enemy in defilade, hiding behind a rock or tree. For example, the computer-controlled and electronically driven weapon can fire up to 200 rounds per minute, uses a dual recoil firing system and a semi-closed bolt firing mode, Army information says. The new tank may quite likely use a futuristic, lightweight 120mm cannon first developed years ago for the Army's now cancelled Future Combat Systems, or FCS. FCS worked on a series of leap-ahead technologies which, in many instances, continue to inform current Army modernization efforts. The FCS program developed next-generation sensors, networking, robots and a series of mobile, high-tech 27-ton manned ground vehicles, or MGVs. The MGVs included a non-line-of-sight artillery variant, reconnaissance and surveillance, infantry, medical and command and control variants, among others. One of the key vehicles in this planned future fleet was the Mounted Combat System, or MCS. The overall MGV effort was cancelled by former Defense Secretary Robert Gates in 2009 because Gates felt that a 27-ton common chassis was not sufficiently survivable enough in a modern IED-filled threat environment. Although the MGVs were engineered with the so-called survivability onion of networked sensors and active protection systems to identify and destroy approaching enemy fire at great distances, many critics of FCS felt that the vehicles were not sufficient to withstand the wide range of enemy attacks should incoming fire penetrate sensors or hit targets in the event that the sensor malfunctioned or were jammed. The Army's MCS program developed and test-fired a super lightweight 120mm cannon, called the XM360, able to fire existing and emerging next-generation tank rounds. The lightweight weapon being developed for the MCS was 2 tons, roughly one-half the weight of the existing Abrams 120mm cannon. The MCS was to have had a crew of 2, a .50 caliber machine gun, and a 40mm automatic grenade launcher. In fact, the Army's recent combat vehicle modernization strategy specifically mentions the value of adapting the XM360 for future use. Next-generation large-caliber cannon technology. The XM360 next-generation 120mm tank cannon integrated with the AAHS will provide the M1 Abrams a capability to fire the next generation of high-energy and smart tank ammunition beyond line-of-sight or LOS ranges. The XM360 could also incorporate remote control operation technologies to allow its integration on autonomous vehicles and vehicles with reduced crew size. For lighter weight vehicles, recoil limitations are overcome by incorporating the larger caliber rarefaction wave gun technology while providing guided, stabilized LOS, course-corrected LOS, and beyond LOS accuracy. Army tank developers said the potential re-emergence of the XM360 is indicative of the value of prototyping and building subsystem technologies. The MCS was test-fired at Aberdeen Proving Grounds, MD, in 2009. The platform used an aluminum turret and 3-man crew using an automatic loading system. Also, the MCS was engineered to fire 120mm rounds up to 10 kilometers, what's called beyond line of sight using advanced fire control and targeting sensors, General Dynamics developers explained at the time. Special new technology was needed for the XM360 in order to allow lighter weight cannon and muzzle to accommodate the blast from the powerful 120mm tank round. Elements of the XM360 include a combined thermal and environmental shroud, blast deflector, a composite built-over wrap gun, tube modular gun mount, independent recoil brakes, gas-charged recuperators, and a multi-slug slide block breech with an electric actuator, Army MCS developmental documents describe. A lighter weight, more mobile and lethal tank platform will be necessary to adjust to a fast-changing modern threat environment including attacking RPGs, anti-tank guided missiles and armor-piercing enemy tank rounds. Increased speed can be used as a survivability combat-enhancing tactic, adding that there are likely to be continued urban threats in the future as more populations migrates into cities.